Alright, so guys, we talked about this today in class. You have a basic cosine function. Y equals cosine x. It starts out at its highest point. 2 pi units later, because that's the period of the function, it starts repeating the pattern. Halfway in between, it will be at the bottom of the cycle, right? Which is 1 unit below the center line. This is your center line, right? Since k is equal to 0. We can tell that there's been no scale change done. A and B are both 1s. No scale change whatsoever. HK, nothing's been added or subtracted to either the x or the y. So HK must be 0, 0. So we looked at this. This is a generic equation for cosine. And you need to get familiar with this because you can easily see H and K, H here, K here, phase shift for the x, vertical shift for the k. This is your center line. Keep that in mind. A and B represent your scale changes. Okay, and we can talk about the rules. You should be familiar with these 2 different rules for scale changes and translations. Now, in the cosine graph, as we mentioned in class, cosine HK sits on the center line underneath a maximum. Since the amplitude on the cosine wave is just plain old 1, HK is 1 unit underneath the maximum. Now, if we start stretching this or shrinking it, that's going to change the amplitude. Then we will have a different distance to go up to find our first point. So the first one that we worked on in class was this graph, this equation. Now, I had you look and find HK, and HK was pi over 2, right here. And the k value was 2. So we could easily find our center line. That's the first thing you want to find is your center line. Then we locate HK. Obviously, since I'm making the scale, pi over 2, comma 2 is going to be a nice coordinate. It does not sit on the cosine wave. It actually sits underneath the maximum. And since there's been no scale change on this, there's been no multiplication going on here, and no multiplication or division going on over here, then the unit 1 is still my amplitude. So my maximum value is at 3. And so there I find my first point right here. And I know that the period has not been affected because there's been no horizontal scale change. That's the part that would stretch or shrink this direction. And since none of that has gone on, the length of the cycle is still 2 pi. So 2 pi units later, we are back at another point where it's reaching the maximum. So that's the second point I find. Halfway in the middle, we're not at a high value, we're not at a center value, we are at the bottom of the wave. Alright? The lowest point, which is 1 unit below. And then you can find the points that are in between this one and this one, so you can draw the curve. What if there was a scale change? We talked about this one in class. We talked about how HK sits at 0, 0 for this because there's been no translation. Based upon the rule states what you would use in order to get rid of the 4 and get rid of the 3 and get back to just x and y. And that would be 1/4 x and 3y. So we have done a shrink. This is a horizontal shrink. By 1/4. And that's going to affect the period of the function. And a vertical stretch by 3. And that's going to affect the amplitude. Well, the old period was 2 pi. So if we multiply by 1/4, we get pi over 2. The old amplitude was a 1, and if we multiply by 3, we get 3. Basically, the scale change is going to be your amplitude. Not basically, it is. I see absolute value bars here. I put them in there, but I'm guaranteeing you, and I guaranteed you in class, that I'm not going to choose an A and a B value, which will be negative, because we're not going to do any reflections. I just want to get you to stretch and shrink this thing normally. I'm not going to try to trick you with negative multipliers. So here's my graph. HK sits here. This time, the maximum is 3 units above, and we have to go over here to pi over 2 to find another place where we start the wave over again. Halfway in between, we're at the bottom of the wave, which is 3 units below the center line, and we can find the points in the middle and draw the wave. What if we try to put them together? We try to have a scale change and a translation all at the same time. Well, you'll notice that this 4x minus pi is not in the same form as x minus h over a. So the very first thing I want you to do is I want you to kind of modify the way the equation looks. Now I'm going to do that by taking 4x minus pi, which can be divided by 1. Anything is divisible by 1. And instead of doing something, some of your friends might talk to you about factoring something out. Don't listen to them. Their teacher, I don't know, has a confusing way in my opinion. Instead, if we want that 4 to become a 1, we take the reciprocal and we multiply the top of the equation and the bottom of the equation by 1/4. Obviously, if this was something like 1/3, we would be multiplying by the reciprocal, which would be 3. But in this case, we've got a 4 to start with, so we're multiplying by the reciprocal, which is 1/4. Now, if I distribute that in, I'm going to get x minus pi over 4. And on the bottom, I'm going to get 1/4. Now, this looks an awful lot like what we were showing you earlier. And you can clearly see h and k. H is over here, right? H is going to be your pi over 4. K is going to be your 2. A is 1/4. B is 3. We can easily identify those 4 parts, A, B, H, and K. If A is 1/4, then the period is 2 pi times 1/4, which is pi over 2. If the amplitude is 3, or if B is 3, then the amplitude is 3. And HK is your starting point, which is underneath the maximum. Now, so I found my center line, K equals 2. And I identified on my graph where pi over 4, comma 2, that's your starting point, right? HK. We know that that sits underneath the maximum. It does not sit on the graph. So I use the amplitude and I go up and I find my first point. Now remember, the period is what's going to be used to calculate the next place. Now that period is pi over 2. So I have to go pi over 2 units to the right. Well, pi over 2, remember, is like 90 degrees. Well, if this is pi over 4, that's 45. So we're at 45, and we add another 45 and another 45 to get to the next place where we're going to start over at that. Halfway in between, we're all the way at the bottom. Now remember, if this is 3 units above, and the center value is 2, then 3 units below 2 is -1, which sits below the x-axis. And then we can find the points in between and draw the curve. Now, we also need to think about sine. Sine has a period of 2 pi and an amplitude of 1. We talked about it yesterday in class, how it has a basic shape that looks like this. Still 5 points to draw the basic sine, 1 cycle of the sine wave. When I draw my points, I start with this one, HK. Then I jump all the way using the period to the place where it starts over. Then I jump all the way back to the middle, and it's going to be back at the center line. Halfway in between here and here, I go up using the amplitude, and halfway in between here and here, I go down using the amplitude. And that's how I graph my 5 points on a sine wave. Okay, now, clearly from the original function, nothing is being added or subtracted, so hk must be 0, 0. Now, how would I describe hk on a sine wave? Well, first of all, it sits on the center line. It sits on the curve. That's different from the cosine function. And if you think from left to right, it would be on the way up. Kind of like a roller coaster idea. You know, if you're traveling on a roller coaster, you'd be on the way up versus the center line on the curve on the way down. It's not that one right there. It's definitely this one. Sorry, can't see that. So we can think about graphing some of these, such as y equals, here I'll start off with y plus 1 over 2 equals the sine of, sorry, couldn't see that, I know, 2x plus pi. Once again, this side over here doesn't quite look like x minus h over a. So I'm going to do a little bit of work on that, right? So I got 2x plus pi over 1. And I'm going to take the reciprocal of the x coefficient, which is a half, and I'm going to multiply the top and the bottom by that. Giving me x plus pi over 2 divided by 1/2. So now my graph or my equation looks a little bit easier to find a, b, h, and k. A right there is a half. B is 2. And then h and k. H is, be careful, negative pi over 2. So we must be shifting to the left. And the k is negative 1, so we must be shifting down. Of course, if the period is 1, or if the a value is 1/2, then we take the original period and we multiply by the multiplier, giving me 1 pi. And of course, the amplitude, which comes from this stretch, used to be a 1, but now it's 2. Sorry, there's like a billion points all over it. I think it's from the ink leaking through the page. So, if I want to graph this thing, first I find my center line. Okay? That's k equal to negative 1. I'm going to be moving this thing to the left, pi over 2, so negative pi over 2. So, that's pi, 2 pi. So hk, negative pi over 2, and negative 1 is right here. That is a location on my curve, according to what we know about sine functions. Now, how far do I have to go to find the next place where it starts the cycle over again? Pi units, according to the period of the function, is pi units. So on my graph, that's 90 degrees and 180. So this is the location where it will be repeating the cycle over again. Halfway in between, we are back at the center line. Halfway in between these two, we're at the top. Well, what's the amplitude? The amplitude is 2 units. So you got to go up 2 units to find that point. And halfway in between these two values, we would be at the bottom of the wave coming down. And so, here's your sine wave. As Bill Engvall would say, here's your sine. Tangent. Remember at negative pi over 2, and positive pi over 2, and I'm only going to draw one cycle because it goes on forever and ever. It's got a center point right there, and you can draw that shape of the graph. We don't get too picky on the tangents. HK being 0, 0 sits on the center line in the middle of the cycle. Okay, so on center line. Middle of cycle. I know we have many more of these things either direction, but this gets you the idea. So I promise I will only do only scale changes on tangent. I'm not going to get into translations because those get kind of messy. So you need to be able to handle things like this. Okay, so let's think about what happened. You can either think in terms of the scale change rule, which would be 3x and 1/2 y, or you can get it in the form we need it in, right? Okay, that 2y is over 1, and if we multiply the top and the bottom by 1/2, we get y over 1/2 on the left side. And inside there, that 1/3 x, remember that's the same thing as x over 3 inside here. So we could say that's equal to tangent of x over 3. And then it looks a lot like what we're used to. A is 3, b is 1/2. And as I promised you, there would be no translation at all of the tangent function. So what's the period? Be careful. The original period of the tangent function was 1 pi. We're multiplying it by 3, so it's now going to be 3 pi. Amplitude, there is none. Remember? No amplitude. So that vertical stretch is actually even going to be hard to see, hard to notice. I probably won't even do a vertical stretch. I'll probably just do a horizontal stretch. So on your scale changes, I'm only going to do a horizontal stretch for quizzes and tests. Okay. Now I know for sake of this argument, I've got a multiplier of 1/2, but it's so hard to notice you're really not even going to be able to tell, unless I use exact coordinates, which I'm not going to do. Okay, so the distance between these parts of the graph has to be 3 pi. Well, in order to do that, this, you're cutting that distance in half, so this part of the graph is 3 pi over 2, and this part of the graph is negative 3 pi over 2. And since I didn't do a scale or a translation, HK sits right there in the middle. And I'm not going to get into, doing the ugly points, trying to understand which is which. So all I'm getting at is I'm going to do a horizontal stretch or shrink. I guess I could put or shrink on a quiz or test. I'm not even going to do a vertical. So that really simplifies things for tangent. Okay, we'll practice in class.